that are new, some things are not new. Similar triangles. Do you remember similar triangles from grade, I think 9, 8? Yeah. In order for triangles to be similar, they must have the same angles, and the lengths of the sides will be at a similar ratio. So that's a grade 9, I think, concept. When we label our triangle, this might be new to you, okay? The uppercase letters are going to be the vertices. So uppercase A, B, C would be your vertices. It's a bigger book than last time. Okay, so, and then how we label the sides, I know often in the past, you would label them like side AC or side BC. You can still do that, but for the sake of our formulas and for the sake of simplicity, when we label sides, we're going to use the lowercase letter opposite the angle. So side BC, we'd actually call side A, but lowercase a. So sides are lowercase letters. Opposite of angle B would be side B, and the side opposite of angle C would be side C. Okay. And this might not be news to you, but the largest angle will always be opposite the largest side. And that's the same thing with smallest. The smallest angle is opposite of the smallest side. Think of like an alligator, right? Big angle, you're going to have a big opposite side, close the mouth, big small opposite side. So you've heard this one a billion times. Angles in a triangle add up to 180 degrees. Okay, so for example, say this is an isosceles triangle here, and those two sides are given, and let's make this a 40-degree angle. If it was an isosceles, what do we know? We wanted to solve those two unknown angles. The two bottom angles are the same. Okay? So I'm calling them alpha. So how would I get them then? If they're the same. What else do we know? Yes. Beautiful. Take 180, take away the 140, or take away the 40, and divide it by 2 because they're equal. So that would equal 140 divided by 2 is 70. So they're each 70 degrees. Okay, I'm going to quickly run through this. You know Pythagorean theorem, right? You've seen it so many times. You know your hypotenuse is the longest side. It's always opposite the 90 degree. If I was looking for, say, side A, how could I change the formula? A squared equals what? Yeah, C squared minus B squared. Or if you wanted side B, you could go C squared minus A squared, okay? So that, we can just, you know that. But it only works for what? Right triangles. Only for right triangles. So there has to be a 90-degree angle. Okay? If it does not have one, you cannot use Pythagorean. You may try. I've seen it. It's funny. But it's not right. You can't use it. Okay? All right. Let's look at it. So let's determine the value of x as, let's make it interesting, an exact value. So in order to find x, what do we need to find first? Y. Y squared is equal to 9 squared minus, because it's the hypotenuse, 6 squared. So your hypotenuse minus the other side squared. which is, what's 9 squared? 81 minus 36 is 45. Now, we're going to answer as an exact value. So, if I type in my calculator root 45, does that give me an exact value, or is that approximate? That's approximate, right? So we're going to leave it as a radical right now, because that's an approximate. So we don't want to type that in. We're going to leave it as y is equal to root 45, because that's exact. I'm not simplifying it because I still have to work with root 45. It's not my final answer, so there's no need to simplify it. So let's solve for x now. X squared is going to equal to y squared plus 3 squared, right? And what's y? Root 45. Here's what's really cool about squaring a square root. They're opposite of each other. They cancel each other out. So when you square root 45, it just equals 45. That's one of the benefits, especially if you're going to have to reuse it in Pythagorean theorem, just to leave it as a radical. So 45 plus 9. 4. That adds to 54. So x is equal to root 54. So we're going to take it one step further. We don't want to put that in our calculator because we want it as an exact value, so I do not want a decimal. We're going to take it a step further, and we should simplify a radical. Okay, so radicals should always be fully simplified. So what does that mean? You took a unit back in grade 10 called roots and powers. And in roots and powers, you learned how to simplify radicals. Maybe you remember, maybe you don't. Okay, so what we do is you have to remember your perfect squares, right? Hopefully you have those memorized. I would hope that you do, because you're a lot quicker with your math when you have these memorized, right? So all of these numbers, okay, so obviously I don't need to keep going, so we want to look at our perfect squares, and we want to find the largest perfect square that's a factor of 54, that will divide into 54. Okay, do you remember this? Sort of, maybe not. So the largest one that will go into 54. Now obviously we're not going to, like, 54 divided by 81, it's not going to work. You're going to start lower. Will 49 go into 54? I'm going to work backwards because I want the largest one. And give me a whole number. No. Okay, so 54 divided by 49 does not give you a whole number. So not that one. Okay, how about 36? 54 divided by 36, does that give me a whole number? Not a whole number. It's a beautiful number, but it's not a whole number. Okay, what about 25? Will 25 go into 54 logically? No. Okay, 16. Let's check. No. How about 9? Yeah, if you know your times tables, you would have been done already. Okay, 9 times what? 9 times 6. So we're going to write that as root 9 times root 6. Because, I don't know if you remember this, root A times B is equivalent to root A times root B. We did that back in grade 10. When you simplified radicals. Does your brain hurt yet? It's a lot coming at you from grade 10s today, grade 10 stuff. So we're almost done, because what can we do? Asher, do you know? No? Why did we do that? Why did I need one of the numbers to be a perfect square? Because it's fun? It becomes 3 times root 6. What is the square root of 9? 3. We want a perfect square factor because then we can actually square root it. And what's the square root of 9? It's 3. So 3 root 6 decimeters is the exact value answer. Fun? We just brought in all this stuff. That's good. You try this one. Okay, I'd like you to try this one. So, diagonal of a square is 13 meters. You are to find the side length. There's multiple methods you can use. I'd like you to try this, solve for the side. You can call it whatever you want. I'm going to call it x. Okay? What could you do after that? What must you do, actually, to get x by itself? Divide by 2. And then all you have to do, square root that. Maybe 2 decimal places or 1 decimal place is fine. Let's do 1 decimal place. 9.2. Did anyone solve this a different way? No? I've seen this before. It only works for a triangle. A square, and it's diagonal. So that's going to make, these are 90s, these are going to be 45 and 45. And it has to be 45, right? Because it's an isosceles. So those two angles are going to be the same. So you could use trigonometry. You could say, okay, with this angle here, this would be adjacent, and this would be hypotenuse. So you could have done cos of 45 equals x over 13. That would have worked as well. Your adjacent divided by your hypotenuse. Okay. And then times both sides by 13 to get x by itself. And that would also give you 9.2. So that's another option too. Okay. All right, so let's talk about SOHCAHTOA. Again, only for right triangles. There's rare occurrences that it's going to come up in this unit. It won't be often. It's not going to be like a question on your test that's just a right triangle. You're going to have triangles that might be an obtuse triangle and also a right triangle with it. So you'll have to use the new type of trigonometry you're going to learn, and maybe one part of it is also using SOHCAHTOA. So you still have to know SOHCAHTOA, but it's not the main focus of this unit. So SOHCAHTOA, you have to know how to label a triangle. It's only, again, for right triangles. Hypotenuse is opposite of what? The hypotenuse. Opposite of the right angle. Because that's the largest angle, right? 90 degrees is the largest angle, so the largest side is opposite the largest angle. What would we call this side over here? Opposite, because it's opposite the acute angle. And the one right below, only thing left. So beside the angle is adjacent. Pretty simple. You do need to remember this. Your calculator has to be in degree mode. So if you're not in degree mode, which you're probably not, please make sure you are at this time. Push mode and degree. Degree. Okay. All right, let's look at the next page. Let's get through this page because there's something else I'd like to talk about today, and that's starting to rationalize. And so I want to go through this pretty quickly. Okay, so one of the questions that always seems to stump students on a test, whether they're in 10C or 20-1 or whatever, is if the question is asking for sine A, not angle A, but for sine A. So if, or cos A or tan A or whatever. So if the question is asking for sine A, okay, determine sine A. So many times students will try and type that in their calculator and push the sine button. But really, what are they looking for? What is sine A equivalent to? So sine A is equivalent to, on your formula, well, on your grade 10 formula sheet, sine of your angle is equal to what? See? You're stumped already. Like, what are you asking? And this is what happens on a test. Let's go back. Sine of an angle is equal to what? Opposite over hypotenuse. They're just asking for the ratio. Okay? Sine of any angle is equal to the ratio of the two sides. And so the question is looking for the ratio of opposite over hypotenuse. Since sine of your angle is equal to opposite over hypotenuse. Ooh, that's scary. So if we're looking at angle A here, and I want the ratio of sine A, of opposite over hypotenuse. According to the angle A, what's opposite of angle A? 4. And what is the hypotenuse? 5. Cos of A would be the adjacent of A over the hypotenuse of A compared to A. Well, hypotenuse doesn't change. So what's the adjacent? 3 over 5. Okay. And last, tan is opposite over adjacent. So what's opposite from A? 4 divided by adjacent to A? 3. So I'd like you to try for angle C now. Same idea. Find sine C, cos C, and tan C. So now, what's the opposite of C over hypotenuse? Adjacent over C. So your opposite and adjacent will change depending on which acute angle you're looking at. Should have 3/5, 4/5, and 3/4. Okay. Good? Easy. Once you know what they're asking, just often students forget don't understand what they're asking. It's the hardest part. Okay, what if you know the ratio, but you're looking for the angle? How do I get angle A here? Do you remember? Whenever we're looking for an angle, what are we going to have to use? Close. What do we call that? Inverse. The negative. Yeah. The tan to the -1. The inverse tan, we call that. So whenever you're looking for an angle, we're going to use the inverse button. Second tan. Second tan. So as long as you have to be in degree mode. The easiest way to check if you're in degree mode is tan 45 should equal 1. So if tan 45 equals 1, you know you're in the right mode. If you're nervous, I think I am, I don't know. That's a good way. So second tan, 1.57. There it is. So the nearest degree is 50 something, yep, 58. Okay, so your ratio can be shown as a decimal, it can be shown as a fraction. So again, if I'm looking for theta here, I would type in what? What do I do? What do I find? We just said it. You can do it. You're so quiet. Come on. What would I type in? What do I need to do? When you're looking for an angle, we use second cos, inverse cos of the ratio of 2/3. So second cos 2 divided by 3. That's the nearest degree. 48. So we're going to try a couple triangles, and then we're going to get into rationalizing. something new? Is it all coming back to you? Might have been a while, especially if you did like math first semester last year. Then it's been a long time. All right, solve the following triangle. Do you remember what it means to solve the triangle, by the way? Find all sides and angles. That does not look like a right triangle. Oh well. I don't claim to be an artist. Okay, your right angle is side, or a vertex what? Which letter? E. So E is the 90. D is 24. It doesn't matter where you put it. I'm going to put it at the bottom. 24 degrees. And side EF is 7.2 centimeters. What do you want to... Let's start by solving for side ED. I'll call that little f because it's opposite of angle f. Okay, I'll make this bigger. Zoom. Is that better? Oh no! There you go. Okay. So let's solve for little f. So I have 24 degrees. So based on 24, what's 7.2 called? Opposite. And what would be little f? Adjacent. So which ratio would we use? SOHCAHTOA. I've also heard other more derogative ones, but we'll stick to SOHCAHTOA. 10. Okay, tan of my angle is equal to opposite divided by adjacent. So let's fill it in. Tan of 24, thank you, equals 7.2 divided by f. Okay. Now, here's a problem. Our unknown that we're looking for is on the denominator. So depend on how your teacher might have showed you different ways to solve this. One way is to take tan 24 and put it over 1. And you do that so you have two fractions that are equal to each other, and then you could do the thing I like to hate doing. I hate it as a high school math teacher, but you cross multiply. Okay, that's one method. Did anyone's teacher, that's fine. Like, it's good for grade 10. Yeah, so that's one method, because we need to get the f off the denominator. Okay, so we cross multiply, and you get f times tan 24 equals 7.2. The other method is we need to get it off the denominator, and right now it's being divided by f, so you would multiply both sides by f. It's really the same thing as cross multiplying. It actually really does give the same result. Because what this does is the f's cancel out here. And now we have f on the numerator with tan 24. 7.2. And what would be the next step? Divide by tan 24. So it turns into division when your unknown is on the denominator. And so that's what we want to type in our calculator. 7.2 divided by tan 24. Okay, now, does it say to the nearest anything? Well, they give their answer to the nearest 10, their information. So we'll answer to the nearest 10, 16.2. 16.2 centimeters. Now, if I'm going to use that 16.2 again, I'm going to use the exact value. So you might want to store that as something, because if I have to use that information, we always want to use exacts in the future. So do you remember how to store things? I push STO, which is right above the on button, and then I can choose any letter I want. I can go alpha F and store that as F if we want. I can choose X. I can call it anything I want, whatever letter I want. What letter do you want to use? A. Sure. I'm going to store it as A. Doesn't matter. So how do I get A? Alpha max, alpha A. And so anytime I type A now, that will be that number. It's stored as that number. So if I have to reuse it in the future, it's fine, no big deal. I have it there. Okay? So how do I get the other side, side FD? I'll call that little e. How do I get that side now that I know 16.2? Yes, probably the easiest, Pythagorean. 7.2 squared plus, now I'm going to write down 16.2, but we're going to type in the exact value. 16.2 squared equals e squared. So we can just go ahead and type that in. 7.2 squared plus, so you could go answer, that always works too, second negative, right? We did store it as a, so I can go alpha a squared instead of typing it all in. That's the benefit of storing numbers. Then I don't have to type it all in. You could just use answer though, right? It was a previous answer, so 7.2 squared plus second negative gives you your answer squared. That works too. And then what do we need to do after that? Excuse me. Square root. Oh, I don't know how to breathe anymore. Equals e squared. So square root both sides. And to the nearest tenth, what's that? 17.7. Side e. We need to find one more thing. What is the other missing? Your angle F. How could I get angle F? 180, take away 90, take away 24, which equals 66. Thank you. There you go. So now we've solved that triangle. Example 4. From a 20-meter high fire tower, a fire is spotted at an angle of depression of 2 degrees. Do you remember that? Angles of depression. Does anyone remember what an angle of depression is? Okay. So let's draw a tower. It's 20 meters high. Sometimes I like to draw a little like stand in there. A little person in there. Okay. And they spot, now obviously this is not to scale. They spot a fire. I don't know. This is my fire. It's not very good, but I tried. Okay, they spot some sort of fire. They tell me the angle of depression is 2 degrees. Does that mean that's this angle right there? Nope. That's what students like to do, right? That's when you're first learning about angle depression, that's a common thing. The thing about angle depression is that it always starts from a horizontal line. Same with angle of elevation. So yes, this is angle of elevation because it's starting from a horizontal line. So the angle of depression is from the horizontal down to the line of sight. Oh, that's not. Okay. And here's what's really cool about horizontal lines. Okay. That is supposed to look like a straight line. It does not look straight. Try again. It's a little better. Okay. So if these were two parallel lines, and this is what we call a transversal, that's crossing both lines. This would be our angle of elevation, and this would be my angle of depression from the horizontal down. Okay. Now the cool thing about angle of elevation actually equals angle of depression. They're equivalent. So our angle of elevation, we actually have to draw a little horizontal line here. And the angle of depression would be from the horizontal down to the line of sight. But do you see this? Do you see this Z here with two parallel lines? Here to here to here, right? These two are both horizontals, meaning, oh, it's supposed to be a straight line. Okay, those are, oh, that is not what I wanted. Okay, try again. There you go. Those horizontal lines are parallel, and so that's why that 2 degrees depression is the same as this 2 degrees here, the angle of elevation. That would also be 2 degrees. So we can solve either triangle. If you want, you could make this a triangle as well, right? And make this 20 and solve this upper triangle. Or we can solve the lower triangle. Well, I'm going to solve the lower. Okay? And what are we looking for? How far is the tower, or fire from the tower? X. I'm going to get rid of my that did not go away like I wanted it to. Go away. Okay, what are we going to use? What's 20 called? Opposite. X would be adjacent. And so we're going to go tan. Tan 2 degrees equals our opposite divided by our adjacent. We need to get x off the denominator, so what do? Times by x to both sides. And then divide by tan 2. Okay, so type that in. 20 divided by tan 2. Let's find out to 2 decimal places. Round it to 2 decimal places. Possess? Perfect. Thank you. There's our answer. And so it is a word problem. You should write a sentence. So therefore, fire is blah, blah, blah. Right? I just want to touch on one more thing before we move into rationalizing. And that is, I didn't give you an example where we're solving for x on the numerator. So if x was on the numerator, just really quickly, how would I solve for x? It's usually super easy because just multiply by 15. Get rid of the 15. And so you would type in your calculator 15 cos 30. Okay? It's a lot easier if x is on the numerator. And that would be 12.99. You should get. Okay? All right, so one thing we need to do is talk about rationalizing. Now you have a handout, and that's handout just like an extra assignment for extra practice, okay? But there's no notes section. So what I'd like you to do is the very back page of your notes package is blank. So we're going to write a couple notes on there, okay? The very, very last page, like the back cover, okay? And it'll be good to refer to that as we go through this whole entire unit because you'll need to know how to do that. So we're just going to add some extra stuff. So we're going to talk about dividing radicals, okay? So the first thing we want, so I'm going to title this Rationalizing the denominator. So first thing we're going to talk about before we talk about rationalizing is we're going to talk about dividing radicals. And this will be new to you because you've never done this before unless you did maybe an AP, Math 10 AP, if you were in that. Okay? So you know how when we multiply radicals, we've done that. Just on a side note, you don't have to write this down. Remember, like if I was simplifying root 12, I can write that as 4 times 3, root 4 times root 3. or root a times b is equal to root a times root b, right? That we've done that part. We can use that same idea with dividing. We can, if we had the square root of a over b, that's equal to root a divided by root b. The same sort of idea applies. We can use those dividing rules. So to divide a radical, a couple of things need to be true. To divide a radical, the index must be the same in both radicals, or in all radicals, in each radical. So what I mean by that is you can't divide a square root by a cube root, okay? That's the first thing. Then what we're going to do is divide the numerical coefficients. We'll divide, so you can divide coefficient with coefficient, divide radicals with radicals. So divide numerical coefficients, divide radicand with radicand. Do you guys remember what a radicand is? So a radicand is the inside of a square root, right? So if you have a square root, say this is cubic root there. This little number, actually I'll just use variables. Let's call this a and this x, okay? Whatever's inside is called the radicand. And the little number is called the index. Now our last step is we're going to actually simplify into mixed radical form. This is what we're going to do. Okay, let's try this guy. Root 30 divided by root 6. So because they're both square roots, they're both under radical symbols, we can divide them. So what is root 30 divided by root 6? It's the same thing as root 30 divided by 6, or root, how many times does 6 go into 30? 5. So we can actually divide them. That's what I'm saying. Okay? Let's try this one. 8 cubic root 21 divided by 2 cubic root 3. So when we simplify this, you can divide coefficients with coefficients and radicals with radicals. Okay, take that off for a second. So the coefficient with coefficient and radical with radical. So 8 divided by 2, can that be divided? Yeah, so that equals 4. What is 21 divided by 3? 7. So 4 cubic root 7. Let's try this one. 4 root AB divided by 12 root A. Now, 12 won't go into 4, but can it be reduced? Can we reduce 4 over 12? Yeah, to what? 1 over 3. We can divide both of those by 4, so 1/3. When you divide AB by A, or root AB by root A, what cancels out? The A's are going to be gone. So we're going to be left with, on the numerator, just what's left over on the numerator? 1 root b, you don't have to write the 1, you can if you want, divided by just 3. The root a is gone. Okay. Let's try another one. Example 2. We're going to simplify numerator and denominator and divide. Okay, so let's try 4 root 54 divided by 3 root 8. Let's see if we can simplify this at all. Okay, so 54 and 8, can that be reduced? 4 and 3 can't. We can't reduce that. Can we reduce 54 and 8? Is there something that will go into both of those?
Yeah.
What? 2. We can divide both by 2. So if I divide this 54 by 2, what's left over? 27. If I divide this by 2, it's 4. So now we have 4 root 27 divided by 3 root 4. Now we're going to simplify this. There's a few things we can do to simplify this. Oh, that's 27, not a 29. I don't know why I wrote 29. Oh my gosh! Johnson! I have an excuse. Okay, my brain. 27, better? Okay, thank you. Let's simplify. Can we simplify 27? Is there a perfect square factor that goes into 27? 9. 9 times 3. So we're going to write this as root 9 times root 3 divided by 3 times what? What is the square root of 4? 2. So we're going to change that to a 2. Okay. So notice that when you have 3 things, what's the operation going on between the 4, the root 9, and the root 3? It's all multiplication. You can write a little dot there if you want. And what is the square root of 9? It's 3. So we're going to have 4 times 3 times root 3 divided by 3 times 2 is 6. What's 4 times 3? 12. Can this be reduced in, can we reduce one more thing? Just keeps on going. 2 over 1. So this becomes, you can reduce this to 2 and a 1, or 2 root 3. Do you have to write divided by 1? No. That was a long one. Okay, let's try one more like this, and then we're getting there. Actually, let's move on to rationalizing. Okay, so that's simplifying and dividing radicals. Let's do a couple. That was the first example. Let's talk about rationalizing now. So that's dividing and simplifying, which is important. So now I'm going to talk about rationalizing, which is the important part. Okay. So with rationalizing, the key with rationalizing is that denominators should never have a radical. Just like in simplest form, we do not want to have a radical on our denominator. Okay, we need to get rid of it somehow. And so we're going to learn how to get rid of it. The same thing is with negative signs. Denominators should never have a negative sign in front. Should not have a negative. So what I mean by that is, like, if you had 7 over negative 3, that's not proper, right? Instead, how else could you write that? Negative 7 over 3. The numerator is fine, or you can even put it in beside the fraction. You just don't leave it on the denominator. Okay, so those are a couple of things about denominators. In mathematics, we don't like to have a radical in the denominator. So how do we get rid of it? So I'm going to show you. So if I want to rationalize the denominator here, okay? If I had 1 divided by root 13, like that's a no-no. We have a radical in the denominator. We want to get rid of it. Notice that this is simplified as far as it can. We can't divide any, like there's no simplifying to do here. It's just we're simplified as we can go. Now we rationalize. So how do I get rid of it? What we're going to do is we're going to multiply the top and bottom by that same radical, by root 13. And that's okay, because that's the same thing as multiplying by 1, because we're doing what we're doing to the top, we're also doing to the bottom. So what does that give me? 1 times root 13 is just 1 root 13, or root 13. You don't have to write the 1. Divided by, what's root 13 times root 13? 13. Okay, so why is that? Well, 13 times 13 is 169, and square root of that is 13. So when you multiply two radicals that are identical, you're just left with the radicand that's inside. So for example, if you had root x times root x, that's just equal to x. And so that's how you rationalize. Let's do one more, and then we might come back to rationalizing a little bit more, okay, as the next couple days go on, because I'd like to give you some time to work through some of this trig stuff. So let's do one more here. What if I had, let's do root 5 divided by root 2. Okay. Now, first off, can we simplify the 5 and 2? No, it's fully simplified. There's no more that I can do. I just need to get rid of the radical on the denominator. So what am I going to multiply top and bottom by? Root 2. So multiply the top and the bottom by root 2. Do you know what root 5 times root 2 is? Root 10. And what is root 2 times root 2? Just 2. Okay, not so bad, right? Not so bad. I'm going to do some other examples later on, maybe tomorrow. We can do a couple more examples, but I'd like you to have some time for your homework. So your homework is, you have a handout that has some just angle stuff and then SOHCAHTOA stuff like trigonometry. I also gave you this other handout. So on the front is some simplifying, like what we first did, and the back there's a question on rationalizing, and there's an answer key attached. So we want to make sure that you have this complete by the time we get to the 3rd or 4th lesson. Okay? Because you're going to need to know this, rationalizing, by the time we get there. Alright, so you have some time to work. I'm going to stop this video. It's a long one.